Our general formula used the terms upper curve and lower curve. But what happens when the same function doesn't remain above another for the entire interval we are considering? Sometimes it becomes necessary to add multiple areas together, depending on the function's behavior and the interval of integration. Let's look at this example, which is a little different from the previous one. Determine the area bounded by the curves y equals cosine of x and y equals sine of x on the interval from x equals 0 to x equals pi over 2. Let's get started on this one. The first step is to determine this point of intersection where cosine of x goes from being above to being below. And that value is where sine of x and cosine of x are equal on the interval from 0 to pi over 2. And that happens when x is equal to pi over 4. To find the area of this first section that we have here, we're going to integrate from 0 to pi over 4 the cosine of x minus the sine of x. And then from pi over 4 to pi over 2, we are going to integrate the sine of x minus cosine of x. So since the upper and lower bounds switch at x equals pi over 4, we can calculate each of these areas separately and then add them together. And now that we have our integrals, let's actually integrate. So if we integrate cosine of x with respect to x, we end up getting the sine of x minus the integral of sine of x is negative cosine of x. The two negatives become plus positive, so we have sine of x plus cosine of x, and we're going to evaluate that from 0 to pi over 4. Well, the sine of pi over 4 is square root of 2 over 2, plus the cosine of pi over 4 is square root of 2 over 2. And from that, we are going to subtract the sine of 1 is 0, plus the cosine of 0 is 1. So we have square root of 2 minus 1 as the area for the first one. Now let's try to do our second integral. If we integrate sine, we end up getting negative cosine of x minus the integral of cosine is positive sine of x. And now let's evaluate that from pi over 4 to pi over 2. Let's start with the cosine of pi over 2. The cosine of pi over 2 is 0 minus the sine of pi over 2 is 1. And then we're going to subtract from that the negative cosine of pi over 4. So that's going to be negative square root of 2 over 2. And then minus the sine of pi over 4 is also square root of 2 over 2. So we have a minus 1. And then if we distribute this negative 1 through to both terms, they become positive. So we have root 2 over 2 plus root 2 over 2 again, which is positive square root of 2, and then minus 1. So that's what it simplifies to. The final step in solving this problem is to add these two areas together. And when we do that, we'll have 2 times the square root of 2 minus 2, which is approximately equal to 828 thousandths.